We're going to look at measures of dispersion. It's a continuation of the descriptive statistics that we've been doing. So we looked at the measures of central tendency, where we talked about the mean, the median, and the mode, and how these elements actually change with regards to distribution of data that we're looking at or measurement. So today we're going to focus on dispersion, and basically this is also a very important tool of actually describing your data. So as you say, the central tendencies, we looked at the mean, median, and the mode, and they're used to describe the data set basically. And the measures of dispersion, or sometimes called measures of variability. So these ones are used to describe the distribution of data, okay, how the data is distributed. And at the end of it, we're going to look at whether the data is very far apart from the mean or whether it is very close to the mean. And that will actually explain the set of distribution. Then, so the main things and measures of variability or dispersion, we look at the range, interquartile range, standard deviation, and variance. So the variance and standard deviation, we look at them together because one is derived from the other. So we'll start with the range, and range basically is a simple measure of dispersion where we simply calculate the highest value subtracted by the lowest value, basically the minimum versus the maximum minus the minimum. So we subtract the maximum value from your data set, then you remove the minimum value from it. So this range is not as useful as we would want it to be, so because we're just looking at the highest value and the lowest value. However, it is still affected by outliers, because if you assume you have a very high number which is not in tandem with what the distribution has been, it will end up affecting the range that you will get. However, in normal statistical sense, the range is not as useful. So sometimes, the range is basically the difference between the greatest and the least value, while the quartiles, if you arrange your values in an ascending order, so basically the value that divides the data into 4 equal parts. So once we divide the data into 4 equal parts, so each part is called a quartile. So those parts can either be on the higher level, basically on the lower bits, where we call it the lower quartile. Basically, this is the median of the lower half of the set of data. And on the other half, the upper half, we call that the upper quartile. So sometimes the upper quartile will be called the third quartile. The lower quartile will be called the first quartile. So these quartiles are basically your data set being divided into 4. Therefore, if the median value basically will be what is separating the two, or the median value will be the 50th percentile, or what is at the middle. Okay, so the value that we get basically from subtraction of the upper quartile and the lower quartile is what we call an interquartile range. So this is the range of the middle half of the data, and basically it's the difference between the upper quartile or the third quartile and the first quartile, which is the lower quartile. So if we look at an example where we actually looking at a data set, this data set here, and we want to actually describe the range, the median, the upper quartile, and the lower quartile, and then we find the interquartile range, we can easily find it. So this is a very simple data set. It has very few observations. As you can see, we have 7 observations here. Now this data, as you already see, is already arranged in ascending order, with the lowest being 80 and the highest being 170, but they're following each other. So the first thing is to get the range, and in so doing, what we will first do is the range is subtracting the maximum value, which is this, from the minimum value, which is 80. Okay, and the difference between that gives us a 90. So the median, which is the second thing, the median is basically the middlemost value. So if this data set is made up of 7 observations, then the middlemost value will be the 4th one, because that means we have 3 below it and 3 values above it. So the median value is 115 in this case. So it is something you can easily observe. But as you'll see later on, it is not always this easy to identify the median. Sometimes if you're dealing with a data set which has an even number of observations, for example, if we had 8 observations, then that means we will not have just one value as the middlemost. We'll have 2 of them. So that brings a different dimension. Now, the other part we want to look at is the upper and the lower quartile. So let's start with the lower quartile. So the lower quartile, so first of all, you have to identify where your median is. And that means the other half, the other values below it, and the other half, and the other values above it, those are the ones that you're going to use to get the quartile. So the lower quartile is basically the median of the lower half, okay? The other half that is lower than where the median score is. So we have these 3 values, which are the values below where our median is, and the middlemost value in that sector of values is what we're calling a lower quartile. So our lower quartile in this part will be 100. If you go now to the upper quartile, which basically is the middlemost value of the values above the median. So we have these 3 values above the median. So the upper quartile is this middle value here, which is 120. So our upper quartile will be 120 and our lower quartile will be 100. Okay, so those are the 2 values. So the interquartile range is arrived at by subtracting the upper quartile from the lower quartile. So as you can see, upper quartile 120, what we got here, and 100 from the lower quartile, what we got here. So the range, the interquartile range is 20. So interquartile range is is an important figure. It has far much reaching implications than just the range. Okay, so most of the time, then when you're describing data that is it's not normally distributed, we'll describe both the median and the interquartile range. Okay, so that's the first example. We can look at another example here, and we have a data set here that is made up of these are 3, 4, 5, 6, 7, 8 values. Okay, so these are a bit different because the other values that we got last time, they actually were odd numbers. They were 7. So these ones are 8. The other thing that we can observe from these values, this data set is not organized because we have 27 here, we have a 21, we have a 19, we have 54, as in they are all jumbled up together. So the first thing to do before you do any of these calculations is to organize this data in an ascending order. And then now you can come and calculate your observations. Now, if we now put our data in form of ascending order, we will have 19 as the lowest and 58 would be our greatest value. Okay, so therefore, if we are simply calculating the range, it will be 58, the maximum value, minus 19, which is the minimum value. Now, the median value. Now, as you can see, we have the 3 values below and the 3 values above. In between, we have 2 values, 35 and 37. So how we arrive at the middlemost value is just getting an average of the 2 middlemost values. Okay, so in this case, we'll just have 35 plus 37 divided by 2, we get a 36. So that is our median value. Therefore, the median value is here, that is 36. So all the values, these 4 values below it, will now constitute the data set that we will try and get the lower quartile, and these values above it, so we have 4 of them here, that will also constitute the upper level values. So what is the middlemost value of the lower section? So it will just look again, we find that we have both 21 and 27 as the middlemost values. Therefore, to get the lower quartile, we will actually have to do an average. The same thing will be done for the upper quartile. So the upper quartile will be an average of 46 and 54. So therefore, in this case, the lower quartile will be 21 plus 27 over 2 to get 24, and then the upper quartile will be 46 plus 54 and then get the average and get 50. Okay, so the lower quartile here will be 24, the upper quartile here will be 50. Therefore, the interquartile range will be the 50, then we subtract 24 and we get 26. So that's how we arrive at our interquartile range. Okay. So here you have another illustration where you have a chart that shows the average number of hours that adults spend online, and you're told just find the upper and the lower quartiles. So as you can see, this data is already organized. Okay, so it's ascending. And as you can see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 observations. That means that when you count 4 and when you count 4 this side, you remain with these 2. Okay, that is 14.2 and 13.4 as your middlemost values. So first of all, you have to arrange the data, and you can see this is the arrangement, and actually this is well arranged. Now locate the median to separate them into halves. So as you can see, it will be 14.2 and 13.4. So these values in between here. Then after that, you can get your quartiles. So first find the lower, and then you come and find the upper. So as you can see here, we have 1, 2, 3, 4. So and the fifth value is here. So this you just pick the fifth value, the middlemost value, which is 13.1, and here you just pick 14.9. Therefore, the interquartile range will be the subtraction of these two, but you are able to identify where they are. Okay, so that was the range and interquartile range and the quartiles. Now we can come to the bit of standard deviation, basically variance. Now, how we calculate variance and standard deviation is simple. First of all, you have to get your population mean, or the mean of your sample. Then after that, you subtract the values you have from that mean. Okay, then after you subtract, you square it. Then you get the summation of all those squares of the differences divided by the total sample size, or the total population that you're dealing with. So the standard deviation basically is a derivative of the variance, and it shows the deviation of the observation from the mean. So it is the most used measure of dispersion. Actually, it is the strongest measure of dispersion. So the values of standard deviation tells how closely the value of a data set basically are clustered around the mean. So if, for example, we have this data set, these 4 data sets here. So this data set that has 4 observations. So we have 82, 95, 67, and 82. So the first thing we do here is to calculate the mean. If you add 82, 85, 67, and 82, you will get a mean of 84. Okay. Then you come and now subtract the value minus the mean. This value minus the mean. Okay. So whatever you get, the difference, you have to square it. Otherwise, if you don't square it, the addition of the differences will always give you 0. Okay, so for us to standardize it and we don't end up having a 0, we want to get rid of these signs, or basically the negative sign. So you have to square these values. Okay, and that will now give a better kind of demonstration. Okay, so basically, we're talking about this, if you don't square anything, we will get 0. Okay, whichever kind of data set you have, if you don't square the differences, you will always be getting the zeros. So the standard deviation basically is a derivative of variance. Now, when we are adding up all those values which are squared and divided by the sample size, or the number of people, or the population, we will end up getting a variance. However, a variance is squared. So for us to get the standard deviation, we'll have to get the square root. So therefore, the standard deviation provides a measure of how much you might expect a typical member of a data set to actually differ or deviate from the mean. Okay, so standard deviations cannot ever be negative. And we know that because of squaring. If you square any number, you'll get a positive value. So this is the standard deviation, which is now the square root of the summation of the differences divided by the sample. Okay. So this is now a typical example where we have a data set with 7 observations. So the first thing, as we always do, is to get the mean. So you add these values and divide by the number of the sample. So this is 35 divided by 7, you get 5. Then you subtract each of these values from 5. So when you subtract, you get these values here. Now, if you add these values, you get 0. So what you need to do is to square them. So once you square each value, so square of 2 is 4, of 3 is 9, and so on. So if you add these values, this gives you 28. Okay, this is the summation of the square of the differences. Now, for this, after this, you have to divide with what? You have to divide with the sample. Okay, so if you divide 28 with the sample size, which is 7, okay, you will get 28 divided by 7, which gives you a 4. Okay, now the 4 will be a variance, will be the variance. However, to get the standard deviation, you'll divide by, you'll do the square root, which will give you a 2. Okay, so the 2 will be our standard deviation. So in some instances, you might find that you don't subtract, you don't divide by the number of the sample, which is n here, 7. You subtract you divide by n minus 1, okay, which will give you almost a similar value. So this will give you a standard deviation of 2 and a variance of 4.67. Okay, so that is all about the calculation. So this is what now, and this is a normal distribution, and we assume at the normal distribution our mean is at 0. Okay, and at 1 standard deviation we have 34, and the other side is 34. So we have a total of 68% of the area under a curve being 1 standard deviation. Now at 2 standard deviation, that figure goes to around 95. Okay, so basically this is the normal rule of standard or standard deviations of a normal curve. Okay, so it only applies to a bell-shaped curve, or basically a normal symmetrical distribution. Okay, however, if the distribution is not normal, then this does not apply. This does not apply. Then it is used to estimate the percentage of values within a few standard deviations of the mean. So you can estimate the number of, because it's just the area under the curve. Okay, so that is the normal rule of standard deviation within the context of a normal distribution.